All right, today we're going to do lesson 9.2, and we're learning how to simplify radicals. Now, last week when we started this chapter, we could stick things in our calculator and it would either give us a whole number if it was a perfect square, or it would give us a decimal answer. All right, but what do we do when they want us to simplify and leave a radical in our answer? So that's what we're going to look at today, and we're going to start by learning or reviewing, for those of you that already know this, upside down division. All right, so here are the keys to upside down division. First of all, when you're writing a problem to do upside down division, it's exactly what it sounds like. All right, a good old-fashioned division problem, we put our division symbol over the 54. But when we're doing upside down division, we're going to do the same division bar, but we're going to do it upside down. All right, but here are the keys to doing upside down division. First of all, you can only divide by prime numbers. So let's talk about what a prime number is. Does anybody know the official definition of a prime number? All right, Elena.
A prime number is when it can only divide by the number itself and 1.
Very good. All right, a number that is only divisible by 1 and itself, okay, or a number whose only factors are 1 and itself would be considered prime numbers. So let's list a few of our prime numbers. Elena, do you know our very first prime number?
2.
Very good, because we know that 1 is not a prime number. All right, after 2 would be what, class? 3, and then 5, and then
7,
and then
9,
11. Okay, we got to skip 8 because 2 times 4 is 8. And we got to skip 9 because 3 times 3 will also give us 9. And we got to skip 10 because 2 times 5 will give us 10. But then we get to 11, and what comes after 11? 13. Now, this is usually as high as I go, because past 13, you're not really going to have to think of prime numbers. They might show up as you're dividing, but as far as what you're trying to divide by, this is usually as high as you have to go. All right, now, when you're doing your upside down division, you're going to keep dividing until you reach a prime number. So once you reach a prime number, you're done dividing. You're then going to find your pairs. Why are we finding pairs? And this is important because as you move further in math, all right, you might be looking for sets of 3 or sets of 5, depending on your root. So the reason we're looking for pairs right now is because all of our problems are square roots. All right, when we're talking about a number being squared, what's the exponent? 2. Okay, so we're circling pairs, and we're making the pairs just one of the number. And we'll get to that explanation a little bit more in a minute. All right, then we're going to multiply all the numbers that we've pulled out. So any numbers that come out from underneath the radical, we don't add them together, we don't subtract them, we don't divide them, we multiply them. Okay, and then leftovers go back underneath the radical. All right, so let's look at example number 1. It says simplify the expression. All right, and they want our answer simplified with radical expressions. So if it's not a perfect square, then we're going to leave our answer as simplified as we possibly can. All right, so square root of 50. The first question we want to ask ourselves is this a perfect square? So is 50 a perfect square? Class, yes or no?
Yes.
All right, we got some yeses, we got some nos. Is there a number times itself that will give me 50?
No.
Then is it a perfect square? No. All right. So we are going to do upside down division. So everybody write 50 and then do your upside down division bar. Now, I'm fine with you using your calculator once you figure out your prime number. All right. But you're going to have to figure out what to divide 50 by on your own. Rain, what would you divide 50 by? Now, keep in mind, there sometimes is going to be more than one option. More than one prime number will go into 50. It does not matter which one you choose, because by the end, everybody will have the same prime numbers. So what prime number would you put into 50? All right, but 25. Is 25 a prime number? No, so we can't use one. So think about those smaller numbers that we just made a list of. All right, let me give you some hints for all of you. This number ends in a 0. Any number that ends in 5 or 0 is divisible by what?
2.
By what?
5.
5, okay? This number is also an even number. So what can all even numbers be divided by? 2, okay? So you can use either 5 or 2 right here. Totally up to you, but we'll go with 5 for right now. Now, what is 50 divided by 5? 10, okay? Now, this is where I'm fine if you want to use your calculator as long as you're showing me your work. Now, is 10 prime? No, so we're going to go ahead and we're going to draw another upside down division bar. All right, Ethan, what prime number goes into 10? Okay, again, 5 or 2 would work. So he chose 5. 5 goes into 10 how many times? 2. Is 2 prime? Then I am done dividing. All right, now it brings me to, I believe, step number 3, where I'm circling my pairs. So Aubrey, do I have any pairs? Okay, what are my pairs? Say it again. Well, I've got a pair of 5s. Do I have a pair of 2s? No. Okay, so I've got my pair of 5s. Now you'll notice when I reached my prime number, what I did not do, I did not put the upside down division bar. The reason is, as I'm looking for all my pairs, I don't want to forget about that last prime number. So once you reach a prime number, don't put that division bar anymore. All right, so we've got a pair of 5s. Now what did we talk about the pairs? The pairs become how many of that number?
1.
Just 1 of that number. So the number coming out from under the radical is the 5. All right, are there any other pairs? No. So then my leftovers go back underneath the radical. What is the only number left over this time?
2.
A 2. So my final answer is 5 times the square root of 2. Now for those of you that need to understand why, and that's totally fine, or you need a visual, why does the pair of 5s become just 1 of that 5? So let me show you why. If I were to put 5 times 2 back underneath the radical, all right, what is 5 times 5? 25. And if I'm looking at this as the square root of 25 times 2, what is the square root of 25? 5. So 5 would come out from underneath the radical and the 2 would be left over. So that's why your pairs become 1 and come out. Every single time. The pair becomes 1 of that number and then comes out from underneath the radical, because that's what would happen if you were to work the problem this way. And you can work the problem that way, but upside down division is going to get you there much, much faster. All right, are there any questions so far? All right, look at 48. Is 48 a perfect square? No. All right, so everybody get ready for upside down division. Madison, what prime number goes into 48? 2. All right, so 2 goes into 48 24 times. Is 24 prime? Nope. Kaylee, what prime number goes into 24? How many times?
12.
Good. Is 12 prime, Kaya? Okay, so what prime number goes into 12? Remember, it's even, so this should be quick because all even numbers are divisible by what? 2. So 2 goes into 12. How many times, CJ?
6.
Is 6 prime?
No, ma'am.
What prime number goes into 6?
2.
How many times?
3 times.
3. Okay. Now a couple times along the way, a 3 would have worked. Again, doesn't matter which prime number you choose. You will end up with this right amount of prime numbers by the end if you do it correctly. All right. Now we're looking for what, Chris? We're looking for pairs. Do we have any pairs? We got a pair of 2s here and a pair of 2s here. Now, Chris, the first pair of 2s is going to come out as a what? Good. The pair becomes 1 of that number. And the second pair of 2s is going to become another 2. So we're taking a 2 and another 2 out from underneath the radical. And what does that leave us? Actually, let's do this down here. What are we supposed to do with the 2 and the 2 that have come out from underneath the radical? Never add. Remember, we're going to multiply. Radicals, it's one big multiplication and division problem. All right. So the numbers that come out from underneath the radical get multiplied together. And Chris, what's our leftover that needs to go back under the radical? The 3. So 2 times 2 is 4. Final answer is 4 times the square root of 3. All right. Good job. Any questions? All right. Now let's look at letter C. Again, there's two ways we can go about doing this, but the simplest is to combine your radicals first. That way, if combining them creates a number that is a perfect square, you have way less work to do. All right, now here's the key to multiplying radicals. You can only multiply numbers that are both underneath the radical, or you can only multiply numbers that are both outside of a radical. I could never ever multiply 2 on the outside and the 2 on the inside. It just won't work. All right, so when we multiply the square root of 2 times the square root of 8, we're going to get the square root of what? Class, what's 2 times 8? 16. Again, we can multiply the 2 and the 8 because they're both underneath the radical. What is the square root of 16? 4. So we got to our answer a lot quicker than if we had done upside down division on 8 and left the square root of 2 the square root of 2. You can do that, but it's always best to multiply those radicals together first, and it will shorten and shrink your problem sometimes. Not all the time, but sometimes. All right, any questions? All right, now we're moving on to fractions. All right, we're going to simplify the expression. Again, we're going to use upside down division if we have to. All right, but the first thing we want to do is rewrite the numerator and denominator separate first. We want to look at them separate. That way, it's going to jump out to us a lot easier if we have a perfect square or not. So if we look at letter A, we're just simply going to write the square root of 7 over the square root of 16. Now we're going to start in our numerator. What is the square root of 7? Will it simplify any more, Marcus, than the square root of 7? No. All right? It's a prime number, so we know it's not going to simplify anymore, and it's not a perfect square. So we're going to leave it as the square root of 7. Now, what is the square root of 16? Class? 4. Now, since we are not allowed to leave radicals in the denominator, this is perfect because the square root of 16 changed this denominator into the whole number 4, and we are finished. Because again, I can't do anything to a number that's under a radical and a number that's not under a radical. So I could not simplify the 7 and the 4, even if I wanted to, because 7 is protected by that radical sign. All right, let's look at letter B. Kaylee, what's the first thing we would do on letter B?
Separate.
Okay, let's separate them. So we got the square root of 1 over the square root of 4. All right, and Kaylee, what is the square root of 1? It stays a 1, or it is 1. And what's the square root of 4? 2. Awesome. So my answer is 1/2. Now, remember what we learned last week? Do you notice how the radical sign is already in these problems, these original problems? So which answers are we given? Let me ask it again, okay? The radical is already in the original problem. Remember we learned last week every real number has 2 roots, a positive root and a negative root. But because the radical is already in the problem, which answer are we given? We're giving the positive answer every single time. That's why we didn't write plus or minus 1 over plus or minus 2. Okay, since the radical was already there, the square root of 1 is 1. The square root of 4 is 2. All right, so I just want to throw that out there so you're constantly thinking about what you learned last week as well. All right, example 2 continued. Same thing, we're trying to simplify the expression. Now look at the square root of 10 over 2. So far, we've had proper fractions underneath the radical. All right, 7 over 16, 1 over 4. But what do we notice about 10 over 2? It's improper. So let's try to do the work under the radical before we do any kind of separating. So what is 10 divided by 2?
5.
So now we have the square root of 5. Can the square root of 5 be simplified anymore?
No.
So guess what? Just by doing that little piece of math under the radical, I'm finished. That's my answer, the square root of 5. All right, now look at letter D. The denominator is already a whole number, so I'm not going to do anything with the 3. I'm going to just bring it down and leave it in my denominator. What do I have to do with the square root of 18, CJ? First of all, is it a perfect square? No. And so can it be simplified? All right, so what am I going to use to simplify it? Upside down division. So what prime number is going to go into 18? How many times? Good. Caleb, is 9 prime?
No.
Okay, so what prime number goes into 9?
3.
How many times?
3.
All right. What's my next step, Colton? Circle what? No, look back at your notes. What was step number 3 after we've divided? Huh? Okay, we're going to circle the pairs. So what are our pairs in this problem?
3.
Okay. Don't help them. You can't help them on a test. We've got a pair of 3s. Now, Colton, when that comes out from underneath the radical, what's coming out from underneath the radical? Just one of those 3s. The pair becomes 1. So the pair of 3s comes out as just a 3. And then what's left over? No.
Oh, 9.
Our pair is gone. Our 3 came out. What's the only prime number left? If we're looking along the outside, the only prime number left is a 2. So that's what goes back underneath the radical. Now we have 3 times the square root of 2 over 3. So remember what I talked about earlier. We can work with numbers that are both outside of radicals, can be multiplied or simplified. We just can't do a number outside a radical and a number under a radical. So what can we do to finish this problem? If anything, can we do anything to finish, or is it finished? Mackenzie?
Do the 3 over 3.
What is 3 over 3? 1. Anything over itself is 1. So I can cancel that out and just bring down the square root of 2. Because the 1 will be understood to be outside the radical. But the final answer there is the square root of 2. Because remember, we always have to simplify our fractions. All right, any questions? All right, let's look at this last one. Simplify the expression. Now, we're kind of combining everything we've learned today. We have a 2 and a radical with nothing in between them. So what operation is that? All right, that is multiplication. So if you need to put a dot there to remind yourself, if you want to put the square root of 3 over the square root of 4 in parentheses to remind you, do it. Okay, it doesn't matter to me, but I'm going to use a dot for right now. And then we're going to split this, the square root of 3 over the square root of 4. Now 2 times. Can we simplify the square root of 3 at all? No, so we're just going to leave it as the square root of 3. And what is the square root of 4? 2. Where would we go from here? Jackson? What would you do next?
Multiply.
What would you multiply?
2 times square root of 3.
Okay. Can you actually multiply them?
No.
Okay, so we have 2 times the square root of 3. It's almost like the radical is an x or a y. It's a variable. So we cannot put 2 and the square root of 3 together because one of them is outside of a radical and one of them is underneath. So we just set them next to each other. It's multiplication. All right, and then it's over what, Jackson? 2. All right, do you see anything else we can do?
2 and 2 is 1.
Again, the 2's that are outside the radicals can cancel. They become a 1, and we just bring down the square root of 3. Now, he could have gone back here to this step, and he could have gone ahead. This 2's in a numerator, and this 2's in a denominator, and canceled them out up there. All right, if he had wanted to. But the way he chose to do it was absolutely fine. Any questions? All right. Take a minute and work letter B. All right, Kaylee, what did you do first on letter B? Very good. 27 and 3 are both underneath the radical. So we bring down our negative 2 and we can multiply the square root of 27 times the square root of 3. And what does that give you? 81. Now again, it's always best to multiply radicals together first because sometimes they create perfect squares for you. So, Kaylee, what is the square root of 81? 9. Now, Kaylee, since the 9 has come out from underneath the radical, and there's already a negative 2 sitting outside the radical, what am I going to do with negative 2 and 9? Multiply. Remember I told you, simplifying radicals, it's one big division problem, and then multiplication. All right, there's never adding, there's never subtracting, it's multiplying and dividing. So when something comes out from underneath the radical, it gets multiplied by whatever's out there already. So what is negative 2 times 9, Kaylee? Negative 18. How many of you got negative 18 as your answer? Okay. How many of you were getting there before I started working it? Okay. How many of you have questions? All right, let's look at our last one. right, Elena, what would you do first on letter C?
Multiply 10 and 16.
All right, so when we multiply the square root of 10 times the square root of 16, what do we get? All right, 160. So we have the square root of 160 divided by the square root of 5. So what do we have to do first, Elena? We always start in our numerator. Let's simplify our numerator first. So is 160 a perfect square?
No.
All right, so what method are we going to use to simplify it? Somebody help her. What method are we going to use? Upside down division. All right, very good. Jackson, what prime number goes into 160? Say it again.
Wait, no, not 10 because it's not prime.
Right, 10 is not prime. Good. So what?
5.
All right, 5 works. 2 would have worked. All right, but he's going with 5. Now, this is where your calculator can come in handy, or you can do it without your calculator. 5 goes into 16 3 times. That's 15, right? With a remainder of 1, look where my remainder goes. It goes right beside the next number, and now I'm looking at 5 into 10. How many times does 5 go into 10? 2. Awesome. Is 32 prime? No, so I'm going to keep going. What prime number, Aubrey, goes into 32? Good, it's even, so we know 2 works. 2 goes into 3 once, with 1 left over. 2 goes into 12, 16 times. All right, we know 16 is not prime. Marcus, what prime number goes into 16? 2, how many times?
8.
Good. What prime number goes into 8? Class? 2, how many times?
4.
What prime number goes into 4?
2.
How many times? Are we done?
Yeah.
All right, so notice again, I don't put that upside down division bar underneath that last prime number, or we'll forget about it. All right, leave it open. So now we're looking for what? Pairs. Very good. So we have a pair of 2's and another pair of 2's. Rain, this pair of 2's becomes what? A 2. And this pair of 2's becomes a 2. So we've got a 2 and a 2 outside the radical. What are we doing to the 2 and the 2 that we've pulled out? We're going to multiply. So we're going to put a dot for right now. Now, normally I would say multiply the 5 and the 2, the leftovers, multiply them and put them back underneath the radical. But because we have a leftover 5 and we have a leftover 2, and we can see that this original problem is over a square root of 5, we're going to keep them separate, okay? And we're only going to keep them separate to see if anything will cancel. So, Rain, do you see anything that will cancel now that we have 2 times the square root of 5 times the square root of 2? Over the square root of 5. The square root of 5 over the square root of 5. Because anything over itself is equal to 1. So, class, what is 2 times 2? 4. Class, what's 2 times 2? 4. And since we canceled the square root of 5, now we have the square root of 2. So, I would leave those leftovers separate until you find out if you can cancel either of them. All right? Once you realize you can't cancel them, then we would put them together. But in this problem, the square root of 5 over the square root of 5 canceled out. So 4 times the square root of 2. All right, are there any questions?
No, ma'am.
Awesome. That is how you simplify radicals.